Hi guys, welcome back. We're going to finish up our lesson on 20.1 data gathering techniques. So the first half was all about our different sampling methods, identifying a population, talking about samples and parameters and things like that. So now we're going to talk about making predictions and actually computing some of the statistics. All right, and there's going to be just a 3-problem homework that will be due on Thursday that will be on my HRW. So again, if you need to reset your password for any reason, if you don't remember it, your login should be your Milton email address, but anything like that, I can get that for you if you can't log on. And they're always going to be available, even though we have the due dates, just in case you need to complete it late. Okay, so let's talk about this a little bit. So this says, in the branch of mathematics known as statistics, you work with data. Data can be numerical, such as heights or salaries, or categorical. So this is one of the questions that shows up in your homework assignment, is identifying a certain bit of data as numerical or categorical. So numerical is pretty easy. It's a number, okay? You're given a value. So if you're asking for somebody's height or their salary or their weight or anything that is numerical data. Categorical is more like categories. So eye color, okay, if you're blue, green, brown, those aren't numbers. That is a category. All right, so eye color or political affiliation. All right, that's another one. Favorite book. All right, lots of different things there. So while a statistic like the mean is appropriate for numerical data, so finding the average is good for numerical data, an appropriate statistic for categorical data is using a proportion, which is the relative frequency of a category. So finding the proportion that fit under a certain category. And we can use that to help make predictions. Okay, so let's take a look at this example and we can answer some questions about it. So it says a community health center surveyed a small random sample of adults in the community about their exercise habits. The survey asked whether the person engages in regular cardio exercise, running, walking, swimming, or something else. And if so, what the duration and frequency of exercises are. Of the 25 people surveyed, 10 say that they do engage in regular cardio exercise, and the lists for those 10 people are below. All right. So even just looking at this information, we're told that 10 engage out of the 25. So we could use that to make a prediction about the population, which would be adults in the community. All right. So all adults in the community, we could say maybe have a probability of 10 out of 25 of engaging in regular exercise. So for the 10 people who said they do, let's look at this. So now we've got different pieces of data. The type of exercise, is this numerical or categorical? Well, look at it. It's categorical, right? Because it's not a number. The duration of the exercise, that's numerical data. And so with the frequency, right? How often they do that exercise a week, that is also numerical data. Okay, so now that we have these 10 people, the first question says to calculate the mean duration of exercise for those who get regular cardio exercise. So the mean for duration. So what we'd want to do is take all these up, add them, and then divide by the total, which we know is 10. So you can do this just on a regular calculator. I also have attached from your Google Classroom. If you go, there's a statistics calculator here, which we'll use in the next example. So this is on your stream on Google Classroom. And you can click on this. So you don't need a special graphing calculator to do statistics. You can use this link and that will get you there as well. But this one's pretty easy. We're just going to add this up and divide by 10. You could do this on your phone calculator. All right, so I'm going to add them all up. I get 500. 500 divided by 10 is 50. So I'm going to go down here and my mean average is 50 minutes. And let's check our answer. And that is correct. Okay, so now let's go down and it says, what is the mean frequency of exercise for those who get regular cardio exercise? So here we have a choice, but we still have to go through. We want to find the mean of this column. So again, we're going to add them all up and then divide by how many there are, which in this case is 10. So when I add them all up, I get 30. 30 divided by 10 is 3. So let's go down here, and this would be 3 times per week. And we're going to check just to make sure, and it's correct. So now we could use this to make some predictions. It says use the means to predict for those who get regular cardio exercise the number of hours spent exercising each week. So we want to take the average number of minutes, multiply by the average times per week, and then we need to convert it into hours per week. All right. So we already figured out the average number of minutes in part A up here, 50 minutes. So I'm going to scroll down and we're going to take our 50 and drag it over here. And then the average number of times per week we said was 3 times per week. So we're going to go to our 3, drag it there. And now we need to do our conversion. 1 hour is equal to 60 minutes. So we're going to take our 60 here. And then we just have to do our computation. So we're going to multiply 50 times 3, which is 150, divide by 60, and that gives us 2.5. So we'll put that here and check our answer. Good. Okay, so I'm going to show you this quick little video, and then we're going to do our last example.
I want us to take a look at this distinction between a statistic and a parameter. So let's take a look here. So here's an interesting scenario. There are 1,340 high school seniors in a school district. In a survey of 200 of these seniors, 159 of them said they plan to attend college within the next year, which is awesome, by the way. Now here's our challenge. Determine which of these numbers is a statistic and which is a parameter. Okay, and then we'll use that information to predict the number of seniors who plan to attend college for the next year. Okay, so what's the statistic? The statistic is the information that we collected through the survey. So 159 out of 200 seniors that were asked said they plan to attend college within the next year. So that's the statistic. That's what we found. Now, what's the parameter? The parameter is the number of seniors in the school, and the entire number of students that plan to attend college within the next year. So that's the parameter. Now, the interesting thing is that once you have a statistic, the power of statistics is that you can use the statistic to actually see if you can estimate the parameter. And that's the power of statistics. Now, how would we do that? Well, the way to do it is to consider the parallel ratios. So look at the statistic, seniors in a sample planning to attend college over the total number of seniors in the sample that were asked. And that ratio should equal the ratio of the students in the district planning to attend college, which is the parameter, to the total number of seniors in the district. So if we set up this ratio, what do we see? So seniors in the sampling that said they would attend college is 159, right? 159 out of 200 that were asked. And that equals this parameter, which we don't know, which is the total number of seniors that we think will go to college within the year, over the total number of seniors in the entire district, which is 1,340. And so notice now, this gives us a little simple equation that we have to solve. You can solve this in any way you want. You can multiply through by 1,340. You could look at the cross products if you want and say 200x equals 213,060, and then divide both sides by 200 to see that x is equal to approximately 1,065 students. So what that tells us, using this statistic, we were able to approximate this parameter and say that since 159 out of 200 are going to college, we would estimate, if that's clean data, that 1,065 out of 1,340 will go to college, because those are going to be in the same ratio. These are going to be equal ratios. So given this, we can find this. And so our guess is that this is good, clean, unbiased data, that around 1,065 students will go to college from the district, seniors will go to college from the district, which is actually really great. But even greater is the fact that we were able to use statistics to generate some information from a small population, namely 200 students, and we were able to reasonably accurately predict what's going to happen with a larger number of students, namely 1,340. That's the power of statistics. Absolutely awesome. I'll see you soon.
Okay, so if we wanted to go back and look at the example that we were doing up here, we could use some of this information to make predictions as well. So we knew that there was a total of 25 people surveyed, and this was just the results from 10 because 15 of the people said they didn't do exercise. So if we wanted to look, we can see that running is one of the categorical data. So 1, 2, 3, 4, 5. So 5 out of the 25 people that were surveyed. Okay, so 5 out of 25 preferred running. And 5 out of 25 is about 20%. So if we were given a total number of people in the community, all right, the total number, of adults in the community, we could take 20% of that, and that would be our prediction. Okay, 20% of those adults we would predict to engage in running. Okay, we had 15 out of 25. All right, 15 out of 25 didn't engage in regular cardio or at all, which is 60% of the population. Okay, so we could make a prediction that 60% of the total number of adults do not engage in regular cardio exercise. Okay, so let's look at the last example, and then you will have your assignment to do. So here's a question where we're given some data. All right, ask some questions about it. So it says a ski resort uses the information gained from scanning season ski passes and lift lines to determine how many days out of each season the pass holders ski and how many lift rides they take each day. The table gives the list for the random sample of 16 pass holders. And we're going to calculate the mean number of days skied and the mean number of lift rides, and we're going to use that to make predictions. So these are both numerical pieces of data, because these are numbers, the number of days skied and the number of lift rides. Okay. If you were looking at the types of skis that the skiers ski on, that would be categorical. Okay, but these are both numerical. So I'm going to show you how to compute the means here if you want to use the statistics calculator that I put on Google Classroom. So I've already uploaded the values here, so you don't have to see me type them in. But these were the values for the number of days. All right, so we've got our 16 pieces of data here. Okay, and this is the screen that comes up when you're doing that. And then you just have to click Calculate Statistics. And we're only interested in the mean, but it gives you all this information, which the graphing calculator does too. But if you don't have your own graphing calculator, that's fine. You can use this. So the mean, we've got 12.5625. So let's go back to the question and see what it says to round to. It says round your answers to the nearest thousandth. So that would be the third decimal place. So when I go and look at the mean, so 12.5625. So this 2, I'm going to round it up to be a 3. Now this is very specific because the way the online homework does it, you need to make sure that the numbers are exact. So 12.563. So let's type that in. So 12.563. Now we're going to go down here and for the second one. So they wanted the mean number of lift rides. So now the number of lift rides, this is the second row of data. So I also typed this in under our calculator. All right, so there's our 16 pieces of data right there I've already typed in. I just have to click on the Calculate Statistics, and we're looking for our mean, 12.3125. So again, we want to round this one up to a 3, so 12.313. 12.313. And then it says the predicted number of lift rides taken by a pass holder per season is what? So the total number of lift rides would be number of days, right, times number of lifts. So we're going to take the averages and multiply them together. So I'm not sure whether they want the answer of the ones that we've already rounded or the ones before, but let's type it in and we can check our answer. So let's try taking these two and multiplying them together. So 12.563, I'm just doing this on the calculator off to the side, times 12.313. We want to round this to 3 decimal places. I'm getting 154.6882. So I'm going to stop at the 8. So 154.688. And let's see if they take this as the answer. If not, we might need to go back to our originals. Oh, so it does say correct. So it just says take these two rounded ones, multiply them together, and then round to 3 decimal places. Okay, so there's only 3 questions for you to do for your homework, which is going to be due on Thursday by 2:30, and then we'll start how to calculate shape and center and spread, and we'll be using that statistics calculator as well. So remember, email or message me if you have any questions about getting onto your my.hrw.com account. If you are forgetting your passwords, I can easily reset that for you. Okay, so you guys will hear again from me on Thursday. And remember, I have office hours every Tuesday from 1 to 2. But if you need to set up another time to meet, we can absolutely do that too.